Hello and welcome back. This is another video in geometry for Unit 8, and this is Section 4, and this is a section about the area of regular polygons. So this is kind of an interesting section, but what we want to do is, for our learning objectives, we want to be able to calculate the length of the apothem of a regular polygon, calculate the area of a regular polygon, and then solve real-world problems involving area of regular polygons. So the first thing I want to talk about is this thing called the apothem. Now, the apothem is kind of a weird word. It always makes me sound like I'm saying the word opossum, but I have a terrible lisp, so just bear with me on that. So, an apothem of a regular polygon is a perpendicular segment from the center of the side of the polygon. So this is really important that we know what the apothem is. And so what we've shown here in this regular polygon, this length here is this length A. Okay, now what I've also done, and before we kind of talk about a regular polygon, remember a regular polygon we talked about in the last section is a polygon, so a polygon with congruent sides and angles. Okay. So what I know about this is that this is a pentagon, a regular pentagon. I know that all of these lengths here are congruent, okay, to each other, and I know all the angles are congruent. So now what I want to show you is that when you have this value called the apothem, what I can do, and that's the length from the very, very center of the polygon out to the, that's perpendicular to one of the sides. What I can do from this center is also draw in this distance here and here, okay? And what I have is a triangle. Now, if I did that to all of the sides, okay, then I have 1, 2, 3, 4, 5 congruent triangles. Now, what I can do is I can actually come up with a formula for the area of that, okay? And so what I would do is if I just wanted to talk about one of these triangles, all right, just maybe this one, okay, and I know that this side length over here is side length S. So if I wanted to find the area of that part, okay, the area is just going to be 1/2 times the base, which is S, times the apothem A, okay? Now, if I had that just one triangle, I could multiply that triangle 4 or 5 times, okay, because there's 5 of those triangles. So what I could do, and this will work for any regular polygon, is you could calculate the area. So you can calculate area by using the following formula. Okay, the area would be equal to 1/2 times the apothem, okay, times the perimeter of the figure. Okay, so if you know length S and you know the apothem, then you can figure this out. Okay, this will always work, but it kind of just depends on what you're given in the figure. Okay, so sometimes you're given like this length here, which we call the radius, or you're given the side length, or you're given the apothem. Okay, so you have those side lengths, okay, and I'm going to call this the radius R. So A is equal to the apothem, okay, S is equal to a side length, okay, and this value R here would be the radius, okay, and I think we'll kind of cover all those later. But that's what we got. Okay, so now let's talk here for just a quick second, from this formula. Let me make sure that we know that A is equal to the apothem, that length, and P is equal to the perimeter of the polygon. Okay? And that's what we've got. All right. I will put in a couple of other values here and kind of make sure that or a couple other formulas in case that we're not always just given the apothem or know the side length. Sometimes there are formulas that we can generate just by using the side length, the apothem, and the radius. Okay, and I'll kind of show you those later on. So here we go. Let's go ahead and find the area of this regular polygon. Now we know that the apothem is 12.1 inches, okay, and it's given to us both here and in the picture. But it also tells us that the perimeter is 80 inches. So we want to know what is the area of this octagon. Okay, so we know that the perimeter is just 80 inches, and we know the apothem is 12.1. So it's pretty easy just to use our formula of 1/2 times the apothem times the perimeter. Okay, now the apothem length is going to be 12.1 inches. Okay, and then the perimeter value is going to be 80. Okay, so I'm just going to plug those values into my formula for A and P, and we'll just evaluate. Okay, so I've got area is equal to 1/2 times the apothem length, which is 12.1, okay, that value, and then times 80, okay? And so go to your calculator, and let's do 0.5 times 12.1 times 80, and that gives us an area of 484 inches squared, okay? And that's it. That's all we need to do. Okay, so pretty easy if you're just given those values, all right? It says, now, we also have this thing called the Pentagon, okay? And it's the defense building that's in Washington, D.C. So we assume that the Pentagon in Washington, D.C. is a regular polygon. So what I'm going to do here is kind of outline the polygon here so we know that all of our sides are congruent, okay? And let me just do this, all right? And it says, how much land does the Pentagon cover, okay? So when it asks us that question, how much land does it cover, that's a measure of area, okay? That's an area measure, okay? And that's what area is. You know, area is just how much space does something take up, okay? And what we want to do is we want to say the apothem measures about 2,882.24 feet. So what I know is that if I find the very, very center of this pentagon, okay, and draw a line to the side that is perpendicular, I know that this length here is 2,884.24 feet. Okay, I also know the side length is 921 feet, okay? So because of that, because I know what those are, I already kind of know what I've got. So here's what I've got. I've got area is equal to 1/2 times the apothem times the perimeter, okay? And so now what I want to do is, I know my value for the apothem, okay? I know A is equal to 2,882.24 feet, okay? And then I want to find the value of the perimeter, P, okay? My perimeter, and I just know that this one length is 921, but I have 5 of them, okay? And they're all the same, so I'm going to take 5 times 921, all right? 5 times 921, and that's going to equal 4,605 feet. So my perimeter is equal to 4,605 feet. Okay, so I have this value, I have my apothem value, so I'm going to plug it all into my formula. I've got 1/2 times 2,882.24 feet, and then I'm going to multiply that by 4,605 feet. All right, and I'm going to plug all that into the calculator. So take this value, multiply it by 2,882.24, okay, and then times 0.5. So it's going to give me a total area of, that's a pretty big building. All right, so here's what we got. We've got 663,600 35.76 feet squared. And that's my value for the area of that pentagon, okay, in feet. All right, so that's the idea. All right, so let's move on to the next page. We'll kind of look at some more challenging problems. Okay, on the next one, what we have is the length of an apothem, okay, or finding the length of the apothem. All right, so we're going to find that value. Okay, and hopefully you're given what's called the radius. Now, the radius of a regular polygon is the segment from the center of the vertex, or from the center of the polygon to a vertex. Now, the vertex, those are the corners, okay? So vertex, that means that that's a corner of a polygon, okay? So what we have in this instance is to find the length of this apothem. Now, what I know is that if we have a regular polygon, I know that all of my sides are congruent, okay? Now, the other thing I know is that when I have this apothem, okay, because this value goes from the center that is perpendicular to one of the sides, what that does is the apothem is really a perpendicular bisector, okay, meaning it cuts it in half. Okay, so what happens is you end up getting these two different congruent lengths here, okay? And so because the apothem, and let's write that down up here, okay? The apothem, okay, is a perpendicular bisector to the side length, Okay, so we have that value, all right? And so what I know is that if the whole thing is 8.2, then this distance here is just going to be 4.1 centimeters, okay? And then what we can do is we have a right triangle here, okay? And I can figure out the length of the apothem by using the Pythagorean theorem, okay? So I'm going to do this, all right? If I'm going to try and figure out what a is, I'm going to set up an equation and say that a squared plus 4.1 squared is equal to 7 squared, okay? And we can just solve this using Pythagorean theorem, all right? And so a squared is just going to stay at a squared. If I do 4.1 squared, that's going to give me 16.81, so 16.81, and that's equal to 49. Okay, so now I'm going to subtract 16.81 from both sides and solve for a squared. Okay, so we isolate a squared, and that's going to give me 49 minus 16.81, and a squared is going to equal 32.19. Okay, and then to solve for a, I'm going to take the square root of both sides. So I get that a is equal to, and let's just take the square root of that, is about, and this would be the exact value, okay, 32.19. Okay, this would be exact, all right? So you can use that, all right, as the length of the apothem. Now, if we wanted to approximate it, okay, we would say that a is approximately 5.67, okay? So this is approximate. All right, the other one is exact. The other one, you know, if we operate, this is the one that you want to operate with, okay, because will give you a more precise answer. If you start to operate, and operate means like if I use this in a formula, I'd probably want to use this one to give me a more exact answer. I mean, you're still going to get close if you do this, but, you know, it's kind of depends on, you know, what's going on. So, all right. Okay, so using the radius to find the area of a regular polygon. So if I have this value here, it says a regular octagon has a radius of 15.7. So it gives us this octagon. We know the radius is 15.7. It says, what is the approximate area of the regular octagon rounded to the nearest tenth? So now here's the problem, is that we're not given a side length, we're not given the perimeter, and we're not given the apothem. So we have this kind of a weird issue here. Okay, But what I need to do is kind of use some trigonometry and some other things to figure out this area. Okay, this is where it gets tricky. So what I want to do is this. I'm going to take a look at my polygon, and I'm going to make a triangle here. Okay, make another radius. Okay, and the reason is I need to figure out what my apothem length is. Okay, so I need to figure out what this length is here for A. And I also need to figure out this length here for S. Okay, and so what I can use, if I know what this angle is, okay, I can figure that out. I can use some trigonometry to find out this length here, which would then help me figure out S, and I could figure out A using trigonometry. So let's do that. The other thing that I know is I could figure out what this angle measure here is. All right, and what I would do is this. All right, I'm going to draw all these different radiuses. Okay, and I know that all of these different angles here are going to be congruent. Okay, all these angles are going to be congruent. Now I also know that if I were to go through this and draw in, let's make that smaller, draw in this length here, okay, I know that this whole angle is going to be 180 degrees. Now if I take this angle, I've got 180 degrees. I've got 4 angles in here that are congruent. Okay, so if I take 180 degrees and divide that number by 4, all of these angles are going to be 45 degrees. Okay, all right, so I know that this angle here is going to be 45 degrees. Now the other problem is that I want to cut that angle in half because I'm really concerned about this angle here. So I'm going to call this angle, all right, 45 divided by 2, which is going to be 22.5. Okay, I know that this angle is 22.5 degrees. Okay, and so now I can use that angle then to help me figure out all these other side lengths. Okay, and I can use some trigonometry. So given this angle here, so I've got this right triangle here. All right, I know that this upper angle here is 22.5. Okay, I know my hypotenuse of this is 15.7. So I'm going to find out my opposite side and my adjacent side. Ooh, and it's conveniently called A. All right, so let's do this. Let's figure out what the opposite side is first. So let's set up a trig function for that. So this value over here would be the opposite side, which is going to be opposite over hypotenuse, which is sine. So I would say this, that sine of 22.5 degrees is equal to the opposite side, which I'll just call O for now, divided by the hypotenuse, which is 15.7. Okay, so then if I multiply both sides by 15.7, okay, I get that my opposite side is equal to 15.7 times sine of 22.5 degrees. Okay, and if I wanted to find side length S, okay, I know that S is equal to 2 times my length of my opposite side. Okay, it's going to be double that length. So if I wanted to find S, then I'm just going to take all this, 2 times 15.7 times sine of 22.5 degrees. All right, so if I plug that into the calculator, okay, let's do sine of 22.5, sine of that. Okay, degree. Okay, 22.5 sine times 15.7 times 2 gives me a length of 12.016. So S is equal to 12.016. Okay, that's my side length. Okay, now I can do the same thing to figure out my apothem length as well. Okay, I'm going to do the same thing. Now, if I use my apothem, okay, I'm going to use cosine, adjacent and hypotenuse. So I'm going to say cosine of 22.5 degrees is equal to the adjacent side divided by 15.7. Okay, so I can multiply both sides by 15.7 to move that out. Okay, so my apothem length is equal to 15.7 times cosine of 22.5 degrees. So let's do 22.5 degrees, cosine of that, and then multiply that by 15.7, and we get a value of 15.505. Okay, so we'll say that my apothem length is 14.505. Okay, and that is going to be in feet. Both of these are in feet. So this is feet. That's my apothem length. Here's my side length. Okay, now this is a lot of work. Okay, it's kind of a pain to do all this. All right, so now if I wanted to find my area, I want to just use my formula 1/2 times the apothem times my perimeter. Okay, now my perimeter, I have 8 sides. So P is equal to 8 times 12.016. Okay, so my apothem length A is going to be equal to 1/2 times my apothem, which is 14.505. Okay, and then times the perimeter, which is 8 times 12.016. Okay, so let's plug all that into the calculator. I'm going to do 0.5 times 14.505. Okay, times 8 times 12.016. Okay, so I get a total area now of 697.17 feet squared. All right, and that's rounded to 2 decimal places. Okay, so this is a kind of a tricky thing to do. Okay, there's just a lot of work to find those lengths. Okay, and it's all things that you've done before. All right. Now, do I expect you to do this every time? Okay, no. There are other formulas for regular polygons. I wanted to show you that you don't have to always remember the formulas. If you use some logic, you can come up with the area. Okay, easier said than done, but you can do it. All right, so let's talk about some formulas for regular polygons. All right, and so the first one we have, and this is if you're only given one, so these formulas are used when you are given only one length of the polygon. Okay, so when you are given only one length. Only one length. Okay, so let's go through that. And let's do the first one if you're given the apothem A. Okay, and this would be, if you're given the apothem and you're not given anything else. So you're only given that side length. Okay. And that formula is that, okay, so if your area of your regular polygon would be the apothem squared times n, and I'll talk about n here in a second, times tangent of 180 divided by n. Okay, now when I'm talking about n, okay, where you're given only one length, this is the number, n is equal to the number of sides. Okay, and so we use that value n. Okay, and that's something we can figure out. If you're only given one thing or another, then you can figure those out. Okay, but if you're just given a picture, you know what kind of figure it is, then you know what n is. Okay, all right. On the next one, okay, let's say that you're given the radius r. Okay. And so the area, okay, of that one, if you're given the radius, would be r squared times n times sine of 360 divided by n, okay? And then that's all being divided by 2, okay? So that's the formula you would use for that one, okay, if you're given the radius. Now, if you're given the side length s, so given the side length s, then the area would be s squared times n, the number of sides, all divided by 4 times tangent of 180 divided by n, okay? So, you know, guys, these are just formulas that you can always use, okay? And it kind of just depends on what you're given, okay? If you can use the other method and use this formula, then go ahead and do that, okay? If you have that information, this is going to be a lot easier than doing this. Now, the other thing I want to talk about is that I don't expect you to memorize these, okay? I don't expect you to memorize, okay? Don't memorize, okay? But use these formulas when need be, okay? When needed, okay? But here's the thing, you know, use these formulas because they're given to you, so you want to make sure you have this written down, and I'm not going to go through how to use them, but it'll be something that, you know, if I sit down next to you, you know, that's something we can go through, okay? So I'm not going to do any practice problems on those. But don't memorize, just use them, okay? And then, you know, these are things you just plug into your calculator and evaluate. So, you know, I hope you enjoyed this video. I had a lot of fun making it. And we'll see you soon. Thanks for all your hard work. Okay, bye.